Hello everyone, how are you guys? I hope you all are fine. So, this is our puzzle class, and I have given you a puzzle. So, today we are discussing the solution of the puzzle. I hope you have done the puzzle. So, the puzzle was, yeah, this one. Okay, the Chameleon tribe. On an island, there are 13 red, 15 green, and 17 blue chameleon. Whenever two chameleon of different color meet, they both change into third color. Is it ever possible for all chameleon to become the same color? Okay, so this is our question. So the question is telling on an island there are total three groups. Okay, so one is the group red, group blue, and group green. Okay, so when um, two group people from two group go, I mean one people from this group, any of one group, one people of another two group, any of one of them goes and meet, and after meeting they will change their color and join into the third group. So it is just like that, one green people go, other red go, and they will become two blue. Okay, so now this thing process happens. So the question is, can they ever become of the same color? Now see, what do we know, what do we see in this? There are total, how many total chameleons are there? There are total chameleons, so number of total chameleon chameleon is equal to 13. 13 plus 15 plus 17, that is simply 45. Yeah, so what do we see? Do we see something? So there are total three chameleons, and two comes and changes to other. What we can think? So the approach, so approach, what approach we need to think? So we can think of, I hope you have studied about modular arithmetic, or even you have not studied, that's fine. We will do it without modular arithmetic. I mean, only divisibility and reminders, no mod or congruency. Okay, let us see over here. So there are 13 red chameleon. So we can see there are total three colors, and we want, can it change into one color? So one thought comes in our mind is, what happens when we divide it by 3? Let us see. We are doing random exploration, so we can see what happens when we divide it by 3. So this is approach 1. Okay, so when we divide 13 divided by 3 gives remainder equal to 1. Okay, again now then 15 divided by 3 gives remainder 0. 17 divided by 3 gives remainder 2, right? 7 8 yeah, 2. Okay, now we are seeing that all three remainders of 3 exist. Can we make use of this? So let us think. So now we can see what is, in this question we will use invariant. Let me first explain you all, guys. Invariant. So what is this? So this refer to thing that never changes or is a constant. So what does that mean? So simply invariant is nothing, it is a thing that never changes. Means like, let's say 1, 3, 5, 7, 9. What is invariant over here? So the difference between any two consecutive is invariant, always do. Okay, that means constant. So now how we can use invariant over here? So we can think of it something like this. When, so we can take 3 cases. So case 1 is when one red, one green meet and become blue. So what will happen in that case? So continue on the next page. So what will happen? There will be, see, let's say there are one red guy and then there is what, one green guy, and they both turns into 2 blue guys. Okay, so one red and one green turn into 2 blue. What will happen? So let us see the number of red, green and blue, what happens. So now before, the number of red was, see, before number of red, green, blue, how much? See, this is before and this is after. So before it was 15, no, it was 13, it was 15 and it was 17, right? Let me see that. Yeah, it was that. After that, one red decreased, one green decreased and 2 blue increased. So that will be 19. What happened? Are you able to see something in this number? 12, 14, 19. Let us see the remainders. This will give remainder 0. This will give remainder 2 and this will give remainder 1. What did you see? Remainders are same. Okay. See, it is simple that if you have a number, let's say n, which gives remainder equal to, let's say 2. If it gives remainder 2 by 3, okay, after dividing that n by 3, it is giving the remainder 2. Then if you see n minus 1, what will that give? Simple. 1. And what will n minus 2 give? 0. N minus 3. Again, now the remainder will become 2 again. How? You see, you can take a simple example like, see, if I get n 15, 15 gives remainder, 15 gives remainder. Now let's say what we can take. Let us take 17. Yeah, 17 gives remainder 2. Okay, so after doing 5 3 15, 2. Okay, if we see 16, what does 16 gives in remainder? 16 will give 1, and again 15 will give 0. What will 14 give? 14 will give remainder 2. Okay, so you got that. So after subtracting 1, your remainder is simply shifting 1 0 2 1 0 2 1 0 2, like that. It is simply shifting. So what we saw in our table, so we saw its remainder was 1, its remainder was 0, it was 2, and it was 1. After again 1 minus, all remainders will shift. Okay, again, like this will become 2, this will become 1, this will become 0. Just shifting is happening, shuffling. Remainders are same. Okay, now let us see our case 2. So our case 2 is when red plus blue meet. So what happens? Let us see. We will draw our same table. Let me copy that. Okay, yeah, that's good. Now let us see. So as what happens, 1 red plus 1 blue becomes 2 green. So red will decrease by 1, blue will decrease by 1, and green will increase by 2. So what happened? See, this is 12, 14, no, not 14. This will become 17, and this will become 16. Now again you see the remainder. This is 0, this is 8, that is 2, this is 1. So you will see the remainder is same. Remainder is invariant. Are you seeing that? All the 3 remainders are occurring. Okay, now how we can prove that? After you read that, what we say, modular arithmetic, you will able to prove that. So now case 3. Case 3 is green plus blue, red. So again the graph will be same. Now red will increase by 2, so red will become 15. Green will decrease, and this will also decrease. You can see what is the remainder. 0, 2, 1. Again, see. Now what is the proof that the remainder is invariant? See. Let's say there are 3 numbers, n1, n2, and n3. So okay, yeah, so now you add this by 1, add this by 1, and you add this by 2. No, here you need to subtract. You subtract this by 2, and subtract this by 1, and that you add by 2. So what will happen? Let's say n1 is congruent to some x1, it is congruent to x2, it is congruent to x3. You can skip this part if you haven't studied modular arithmetic. So what will this will be congruent to x1 minus 1, x2 minus 1, this will be congruent to x3 plus 2. Now you see, if all three remainders occurred, what will happen? You see these differences. What is this difference? 2. What? No. Okay, you leave that. You simply see that if you subtract this by 2, if you subtract this by 1, not 2, sorry, that was, yeah, if you subtract this by 1, again, that will be x1 minus 2, this will be x2 minus 2, and if you again increase this, x3 plus 4. Now we know that we can replace this plus 2, because this is congruency, by minus 1, and this by minus 2. Now see, here all remainders existed, so after subtracting 1 from each remainder, you are understanding, all the remainder will be there but shuffled. You can prove this using contradiction. If let's say after subtracting 1, any two of the remainders are equal, this implies that before any two were equal. Okay, that is simple. Let us move on. So what do we saw? We saw that in any case, the remainder given by number of chameleon is not same of any two. That means any two chameleon will not give the same remainder after doing any case any number of times. So the required output is, we want that one color is 45, other two are 0. Okay, so remainder by 3 is 0 0 0. This means that all three remainders are equal. All three are equal. That is impossible as per our what per our observation. So we got a contradiction, that if the output is true, then starting case any two of the remainders need to be same, but in the starting no two remainders are same, so we got a contradiction. So answer is No, no, all chameleons will not become of same color after doing any three cases in any number of times. Okay, so this was simple question. I hope you all have tried this. Okay, thank you guys. Ending the session.